Molecular orbital. What is molecular orbital? Okay, when a similar atomic orbital of two atoms. Okay, when similar atomic orbitals of two atoms are combined to molecular orbitals are formed. Okay, when similar atomic orbitals, different atomic orbitals, not different atomic orbitals. Okay, similar atomic orbitals. When similar atomic orbitals of two atoms, similar atomic orbitals of two atoms are combined to molecular orbitals are formed. One of the molecular orbital is bonding and the other is anti-bonding. One of the molecular orbital is bonding and the other is the anti-bonding. Okay, anti-bonding. Molecular orbitals which have lower energy than the atomic orbitals are called bonding molecular orbitals. Okay, and which have higher energy are called anti-bonding molecular orbitals. The numbers of molecular orbitals is equal to the numbers of atomic orbitals combined to form molecular orbitals, MO. Okay, so molecular orbitals which does not participate in bond formation is called non-bonding molecular orbitals. Its energy is similar to the energy of atomic orbitals. Thus, the linear combination of similar atomic orbitals of two or more atoms give equal number of molecular orbitals. This can be illustrated as, okay, formation of molecular orbitals. Formation of molecular orbitals. Formation of molecular orbitals. Okay. Formation of molecular orbitals. Formation of molecular orbitals. Formation of molecular orbitals. Okay. First, linear combination of atomic orbitals. Linear combination of atomic orbitals. Atomic orbitals. Linear combination of atomic orbitals. Okay. Linear combination of atomic orbitals, LCAO, rule. Okay, rule. The molecular orbitals can be obtained by method of linear combination atomic orbitals, LCAO. The linear combination of two atomic orbitals. The linear combination of two atomic orbitals. Whose function is brought either by adding or subtracting the two wave function of two atomic orbitals. Thus, if psi is the wave function of molecular orbitals obtained from two atomic orbitals of atom A and B having psi A and psi B as their representative wave function, then psi equal to psi A plus minus psi B. Okay? It clearly shows that the linear combination of psi A and psi B gives two molecular orbitals. One of these molecular orbitals bonding and is denoted by psi B, and other is anti-bonding, which is denoted by psi A. Okay? Thus psi B equal to psi A plus psi B, and psi A equal to psi capital A minus psi capital B. The molecular orbital psi B has lower energy than either of the atomic orbitals, which leads to the formation of a stable molecule. The molecular orbital psi B is formed The molecular orbitals psi b is formed by the addition overlap of atomic orbitals is known as bonding molecular orbitals, BMO. Bonding molecular orbitals. The other molecular orbitals psi a, has higher energy than that of either of the atomic orbitals. Psi a is formed by subtracting overlap of atomic orbitals and is known as anti-bonding molecular orbitals, ABMO. Okay? The number of molecular orbitals is always equal to the number of atomic orbitals. Number of molecular orbitals is equal to the number of atomic orbitals. Okay? And the number of molecular orbitals is always equal to the number of atomic orbitals participate in the formation of molecular orbitals. The positive sign indicates that B is formed when the region is atomic orbitals of plus sign overlap with each other in bonding molecular orbitals. The two atomic orbitals have been added. The negative sign indicates that psi a is formed when the atomic orbitals with opposite sign overlap here. Two atomic orbitals have been subtracted, thus according to wave mechanics. Okay? Then psi b equal to psi symmetrical combination. Symmetrical combination. Psi symmetrical combination equal to psi a plus psi b. And psi small a equal to psi anti-symmetric combination. Symmetric combination, okay, equal to psi a minus psi b. Electronic charge density of molecular orbitals. Next is electronic charge density of molecular orbitals. 1 minute. Electronic charge density of molecular orbitals. Okay, electronic charge density of molecular orbitals. As psi square represents the probability of finding electron in an orbital. Okay, then psi b equal to psi capital A plus psi capital B, and psi b square equal to psi capital A plus psi capital B whole square equal to psi a square plus psi b square plus 2 psi a psi b. Okay, the above equation shows that psi a square is less than psi a plus psi b square by a term 2 psi a into psi b. Okay, this indicates that in anti-bonding molecular orbitals there is less charge density between the interacting atoms than non-interacting atoms. Okay, Hence, the energy of anti-bonding molecular orbital is greater than the sum of the energies of the two interacting atoms A and B. Okay? A and B. The different atomic orbitals which combination is follow molecular orbitals. Okay? First orbitals. Atomic orbitals. AO. Second orbitals. AO. Second orbital. Next is type of molecular. Next is type of molecular orbitals. MOS. Okay. S. First orbitals. S orbitals. Second first and px orbitals, atomic orbitals, and pz atomic orbitals, and py atomic orbitals. That is SPX. Next is SPX second orbitals, and next is PZ, and next is PY. Then types of molecular orbitals, that is sigma bond, that is pi bond, and that is pi bond. Okay. The combination of 1s orbitals of A and B atomic to form molecular orbitals has been this is the point, this is A and this is B. Okay. And after combination, one years. Okay. Then 1 year, this is sigma bond. Okay. And 1 year conjugate anti-bonding, 1s, this is the 1s sigma bond formed. Okay. And this is energy E. Okay. And graph is this is anti-bonding and this is bonding. Okay. And the graph energy distance graph. This is origin point, null point, and the graph is this is energy, and this is distance in angstrom, and anti-bonding psi A. That graph is this is psi A anti-bonding. This is anti-bonding, and this is psi G. This is bonding. Okay. This is anti-bonding and this is bonding. Okay. and bonding molecules is this is bonding molecules. Bonding molecular orbitals. Okay, this is bonding molecular orbitals, and this is bonding molecular orbitals. Okay. And this is anti-bonding molecular orbitals. Anti-bonding molecular orbitals. This is bonding molecular orbitals, and this is anti-bonding molecular orbitals. Anti-bonding molecular orbitals. Then this internuclear line bonding. Okay, and this is point A and B. Then this is atomic. This is atomic. Okay, atomic, and this is atomic, and this is molecular. This is molecular. This is atomic, and this is molecular. Okay, this is psi A, and this is psi B. Okay, psi square. This is psi square symmetrical. Psi square symmetrical. Psi square symmetrical. This is psi square symmetrical, and this is a psi square 1s sigma bond. 1s sigma bond. Psi square 1s sigma bond molecules. Okay, this is internuclear line bonding. This is internuclear line bonding. Internuclear line bonding. This is internuclear line bonding. Okay, and this is a point A and a point B. Point A and a point B. Okay, this is atomic. This is atomic and molecular, and This is molecular, atomic, and atomic, and this is molecular, and psi square. This is psi square or symmetrical, anti-symmetrical. Psi square, anti-symmetrical. Okay, and this is a sigma 1s conjugate. Okay, electron probability density vs internuclear distance into nuclear distance. Okay, 1 minute. This is the anti-bonding. This is anti-bonding. Okay, electron probability density, electrons probability density, probability density Bs internuclear distance, internuclear distance. Okay, internuclear distance, electron probability density vs internuclear distance. Okay, then this is A1s. This is B1s, atomic orbitals. Okay, and additive combination. After additive combination, additive combination. This is additive combination. That is also convert in A, B positive additive combination, overlapping up to 1s atomic orbitals, overlapping of two 1s atomic orbitals, and after combination that is changing a bonding resulting molecular orbitals, resulting molecular orbitals. Okay, and in subtracting combination, that is A, and that is B, overlapping of 1s atomic orbitals, by subtraction, atomic orbitals by subtraction, resulting resulting anti-bonding molecular orbitals, resulting anti-bonding molecular orbitals, anti-bonding molecular orbitals. Okay. Condition for the formation of molecular orbitals. Next is condition. Condition for the formation of molecular orbitals. The atomic orbitals form molecular orbitals only when the following conditions are satisfied. First is the combining atomic orbitals must have same energy, must have same energy, so 1s and 2s, so 1s and 2s, 1s and 2s will not combine to form, molecular orbitals combination like like 1s and 2s, 2s and 2p, okay, 2s and 2p, okay, 2p, okay, 2s and 2p, and are not allowed due to greater, 2s and 2p are not allowed, okay, are not allowed due to greater, energy difference, okay. Example in H2, N2, O2, Cl2, etc. Okay. The combining atomic orbitals must have same energy. So 1s, 2s will not combine to form molecular combination like 1s and 2s, 2s and 2p are not allowed due to greater energy difference. Example H2, N2, O2, Cl2, etc. Okay. Second point. For the formation of molecular orbitals, for the formation of molecular orbitals, there must be sufficient overlap between atomic orbitals, the electron density between the nuclei the electron density between the nuclei of two atoms forming the bond is high due to more overlap is that addition overlap of atomic orbitals overlap of atomic orbitals. Okay. For the formation of molecular orbitals, there must be sufficient overlap between atomic orbitals. The electron density between the nuclei of two atoms forming the bond is high due to more additive overlap of atomic orbitals. Third condition. The symmetry of atomic orbitals. The symmetry of atomic orbitals must be the same in direction. Must be the same in the direction. Must be the same in the direction of molecular axis Okay. Thus the molecular orbitals cannot be formed by the overlap of S atomic orbitals of S atomic orbitals and 2py are 2pz orbitals of another atom. 2pz orbitals of another atoms. It is because molecular axis is the x-axis and 2py or 2pz is perpendicular to x-axis, to the x-axis. Okay. Types of molecular orbitals. Next is types of, and third point is the symmetry of atomic orbitals must be same in the direction of molecular axis. Thus molecular orbitals cannot be found by the overlap of s orbitals and 2py or 2pz orbitals of another atom. It is because the molecular axis is the x-axis and 2py or 2pz is the perpendicular to the x-axis. Okay. Types of molecular orbitals.